will dive a little bit deeper on the topic of using metrics in order to estimate and assess the quality of a given search. And so, it's your stage.
Thank you. Guten Tag, Damen und Herren. Yeah, this talk is not going to be in German. It's not about German as well, but since I'm here on stage and I have a German audience, I decided I'll just take a stab at German. Because through the years I've faced it a number of times, and I have this love and hate relationship with the language. Well, why hate? It's not really hate, but from my perspective, statistically speaking, German is mostly composed of words like this one, or this one, or even this one. I've used this last one a number of times through the years, and actually last night I asked Andreas for permission, and he reminded me that this word comes from Otto, so now guys, you have a trademark on this word, you can start charging royalties for it. But I also love the language. You know, you guys come with brilliant insults, like this one. I even tried taking cold showers, but no, I'm not that tough. Or this one, which is apparently also local. It's not across Germany. It's something local in the southern part of Germany. Okay, so a little bit about me. My name is Pavel Penchev. I spent more than 10 years at Fred Hopper, looking at search from various perspectives, from developing to research to product management. And right now I'm part of SearchHub, a small but spectacular startup from Pforzheim, where what do we do there? So we believe that the most important metric for search is whether we help people find what they're looking for. And we have based our entire concept around this, where we're already running with a number of customers, where we're not only improving the accuracy and the conversion for search, but also the overall execution and performance times of search. And today I wanted to talk about something that was just now mentioned as part of a question, which is how do we collect data? Because for our concept, data is the key. Really, that's what we base our product on. So looking at the big picture of our product, there are different components where we take data, the different pipelines and interaction, but I'm going to talk about the far corner over there, about something we call the search collector. The search collector, so why we didn't pick an off-the-shelf solution? Out of all these points, what's a key point is that most analytics solutions are not meant for search. They're just not specific. You always have to modify a lot of things. You have to then do data engineering on top of them. And I think the worst part is where you need your customers to do things for you. So you go in there, can you please implement that on your website? Then they have to go to their integrator and say, we need this. Then there's a whole project coming out, and then you easily waste months trying to get something arranged for your data points. So what we did instead is something we call the search collector, as I mentioned already. It's a JavaScript SDK for collecting of search events, and we are open sourcing it. It's available at GitHub as under the MIT license. I'm going to briefly walk you through our idea and the concept behind the search collector. So the basic architecture is really build your own solution. As mentioned before, we don't think there's a really out-of-the-box solution that can give you exactly what you need. So we decided we'll just provide an SDK with the necessary building blocks, and then you'll be able to compose whatever solution you want. There are three main blocks of main types of components there. Collectors, which help you collect the event that you need, and I'll talk a bit about all of these a bit later. There are context resolvers. Search never runs in isolation. There's always a context, what's happening on the page. And there's the writers components that will pipe the data to your endpoint. So these are the three really building blocks of what we do. And a sample code. So not everyone is technical. I'll just read in human language what this means for us. This sample integration code is something that you would build using this SDK. You would package it and inject it into the client website. So this is code that will execute the end user browser and will be collecting the events for you. These lines of code go something like this. We will first create the collector. We will create a resolver that will be handling the session. So for what a search session means is not, it's not really just one tab. It could be across multiple tabs, and the time span also matters. So this little component helps you define what a search session for a user is. And then there's the endpoint where you want the data to go. We support two types of endpoints, SQS and REST endpoints. And then the interesting part happens, which is attaching the actual collectors. Here I've attached two types of collectors. One is collecting the product clicks, and the other is collecting impressions. So whenever somebody clicks on a product, there's a little code that gets executed, an event gets sent to the relevant endpoint, and the same with the impression. That's all you need to get going with tracking these events. And we have a number of collectors already published. The collector is nothing that complicated. A collector is a really simple interface that anyone can implement if you want your custom collectors to add to this little framework. There's also these type of resolvers and writers that we provide out of the box. I spoke a bit about the resolvers, but again, here, for example, there's a position resolver that will help identify where an element is inside the search result. An interesting thing about the writers is that they plug into each other, and you can also add additional writers. So in this case, we combine all of them in a single pipeline, but if you want to, you can exclude or add more writers so that you end up with exactly the data that you're looking for at your endpoint, packaged in the way you expect it. I'll take a bit more time to talk about this slide. So a part of the reason why we implemented this is that we could not find most of this functionality in other type of products. So the delayed writing is we are buffering events so that when there's lots of events like impressions, a product shown on a page and all that, we don't just write all the time because that will slow the page and it would be a bad user experience. So we keep these things in memory and send them out in batches. So this helps write as many events, collect as many events as you want. And the good thing is that we also keep that across page reloads, so you don't lose any of the data that is relevant. The impression detection, so we detect when a product is shown in the viewport, is also not always found in these products. Another very useful thing is DOM insertion detection. So when you have these scrolling search results that products are added dynamically to the page, that's a pain for most of the trackings and analytics solutions. So we've implemented that, so when a new product comes, it's automatically picked up by the collector. I spoke about the resolvers. Here another interesting resolver is the query resolver. When there's a search or filter event on the page, they create this context for the other events. For example, when a product click happens, you would like to know what was the exact search term and all the filters applied on that page when you recorded the product click. So this is also something we provide. I also mentioned the SQS support. directly writing to Amazon. We found this to be the cheapest way for collecting events. It's just a huge amount of data can be piped through SQS queues, and then you can easily read that. So with SQS support, you can both run real-time analytics, where you really pipe the data and analyze it as it goes, and then because the way we implement our product, we can use that immediately. Or you can do batches and analyze the data later. And the final, it's not really a feature, but I just enjoyed that it worked like that. Test suite for the product. So when you want to test what you did to the framework, you have headless tests to run and test your stuff. Now there was a demo time. Of course, I will not be able to do any demo time because my laptop is over there. But I encourage you to just go at SearchHub, at GitHub SearchHub, Search Collector, and take a look at our at this little piece of JavaScript SDK. You can also visit SearchHub.io to check what we're doing, or talk to any of us in the black t-shirts with the B on the left, and yeah, as well as Otto, we are also hiring, so please come over. Okay, that was it. Thank you, guys.
So at least this little screw up with the technique brings us back on schedule. So, are there any questions? Lots of questions. So.
Hello, thank you for that introduction. In the wake of all things GDPR, I've got to ask, do you have any features of reducing the footprint that users leave in the data?
Yeah.
Any anonymization or?
Yeah, I knew this will come up. So yeah, we don't actually collect anything related to the personal footprint. It's all about search. So we leave it as abstract as possible, not collecting any personal data.
Hi, thanks for the talk. Great to hear about another open source tool for this area. Have you experimented with taking the applet of this and using the REST interface to pipe it directly into a search engine like Elasticsearch, for example, where it could be analyzed?
No, but it is possible to do. So since it's a REST endpoint and you have control over the way you write data, you can immediately pipe to the Elasticsearch interface. And it's going to work out of the box actually if you write just a little writer component.
Fantastic, thank
you. With client-side tracking, there's always the issue of network failures and reliability especially when you collect large batches of data and then somebody enters the subway in Berlin or closes the browser or whatever. How are you dealing with that?
So, as I said, we keep a buffering in memory. So the data is, if we can't send the data stays there. So until the next time that person opens up their page. It's not, it's not bulletproof. It can never work 100%. There's always the possibility of a failure, but we try to to work around this with the buffering.
Hi, thanks for the talk. So, little kind of implementation oriented maybe question. I'm a little unsure about how this impression collector is going to help and what exactly is the purpose of having that. I couldn't really follow that.
Okay. Well, it's a collect first. Again, a reminder: you don't need to use it. So the only thing you need to use really is to figure out what are your needs. So if you don't want to track impressions, just throw them out of the window and not add them there. Otherwise, the impression is you might be tracking the products that appear in the search result, and when they're really shown to the user. So you want to know, did this product show, and when it showed to the user, where was that product in the product list? So you want to figure out, okay, I showed this battery pack. I showed this battery pack at position 5, and then there was other products at position 6 and 7 that appeared that are of interest to me. You might be optimizing a category of searches and where they appear on the page. So it's a kind of interaction and event that you may want to optimize your search for. You may be tracking the negative, so the product was there but nobody clicked on the product. So this is also a relevant metric.
Okay, yeah, that helped, yeah. Okay, thanks.
Welcome.
So I think now we have the perfect timing for the next last question.
Well, thank you for the talk and thank you for open sourcing the library. As it said a lot about the front-end implementation, and we just heard about Elasticsearch as a possible back-end alternative. Can you say more about back-end approaches that obviously you start using the data you're collecting all day?
Yeah. So we do our own post-processing of the data once we consume it, and then we also use Elasticsearch to enrich the rest of the data that we collect. So this is one of the sources of data that we use, and yeah, Elasticsearch plus other custom stuff that we do allows us to make the necessary changes. It's really, so we really use the collector to enrich the rest of the data. That's the key point for us.
And reporting is done, or?
We don't really do reporting at the moment. It could be Kibana, up to you. Yeah.
So I see we have a little time left, so I can pose a question.
Okay.
Is it possible to induce code via the Google Tag Manager, or do you have to put it into the page?
You could probably insert it via the Google Tag Manager. We haven't tried that. It's simpler to insert it directly on the page. In fact, what we do is that we provide a unique URL that we ask our clients to include on their page, and then we control entirely the URL and what really happens and how do we collect the events. The good thing about this approach is that we have a full control over whatever happens to the page, we can adjust to that. So we control if they change something, or if the structure of the page changes, we can add the necessary by ourselves.
Okay, thank you.
Thank you, everyone.
Applause again for Pavel.